All right, we're looking at worksheet 88, and we're doing surface area of cones and spheres. And on the bottom of your formula sheet are your two formulas. Now, in this first formula for the surface area of a cone, that's what we're focusing on. You have pi rs. The pi rs is really the area of this, I don't know, triangle with the curve to it. And then pi r squared is the area of a basic circle, which is like the closing flap or the base of the cone sitting on it right here. The important thing is that you have the radius. So if we're given diameter, we want to put it to the radius. The other thing is we're not using the height as in altitude with that 90-degree drop. We are using the slant height. So that's important. If we have the height and the radius, we find the slant height using Pythagorean theorem. If we're given the slant height and the height, we can find the radius, but we have to watch where we put them in Pythagorean theorem. Now, when we do volume, we will use the height, but for now we're using slant height because we want to know about the surface. All right, so I am going to skip these first couple. You can see you're given slant height. Here's your S, and here's your radius, so you can put that in. Remember, we want exact and approximate. Now, this number 2, you have your radius, but you have the height. And what do we want? We want the slant height. So I'm looking for this. And if you can trace this idea, you see that right triangle. So I have 10 squared plus 24 squared equals the slant height squared. And again, make sure your S doesn't look like a 5. That'd be confusing. All right, you've got your calculators. I'm just going to type in the 10 squared plus 24 squared. I get 676. Now, how do I get rid of that square on the S? Take the square root, and I'm going to do, what was it, 676. I could just hit answer on that too, and I get 26. Okay, that's definitely reasonable. The hypotenuse should always be longer, so the slant height is 26. All right, so now that we've got that, we're going to put it in our formula. Now remember, our formula, I'm going to transfer it here, is pi rs plus pi r squared. So I'm just filling it in. So to find the surface area, I'm doing pi times the radius, 10, times the slant height, 26. I'm really not using that 24 again at this point. Plus pi times the radius, 10 squared. Now, I know it's easy just to want to plop all this in the calculator, but they want the exact answer. So we are going to put the parts in. Take your 10 times 26, that's 260. Attach pi just like you would if it was a variable. And then take 10 squared, which is 100 times pi. So pi times 100 or 100 times pi. And then these are like terms. 260 of these pi plus 100 pi. We have 360 pi, and that would be feet squared. So I've got the exact 360 pi. Now remember, 360 pi is the same as 360 times 3.14. I'm going to go ahead and use my pi key. So 360 times pi, I'm just that easy. Hit enter. And the directions say nearest tenth. So this would be 1,130 point, and it's 97. So what's going to happen? Yeah, the 7's going to round that up, which is going to bump this to 1,131 feet squared. Okay, that's pretty much what I wanted to show you on the front. So take a minute and look. Number 4 gave you the radius and the slant height, so you can jump right in. Number 5 gave you the slant height and the radius. You can jump in. You can't see what I just did there. There's number 3, sorry. Number 5 gave you the height, so you're going to use Pythagorean theorem, so I'll start that with you. 7 squared plus 24 squared equals s squared. And you're going to do the same thing in number 6. 6 squared plus 8 squared equals s squared. So that's your reminder that you need to find the slant height before you can plug it in. Now, go ahead and read number 7 here. A little bit different. Find the surface area, okay, that's the same, of a cone. The height is 12 inches and the slant height is 15. What do I need to find the surface area? What was that formula? Pi rs plus pi r squared. They gave me the height and the slant height. What do I need? I need the radius. Okay, so can you picture this cone? You don't have to draw it. If you can picture this cone, they gave me the height of 15. They gave me the slant height of 12. That's not right. Sorry, they gave me the height of 12 and the slant height is 15. Do you know how I knew I was wrong? Yeah, the slant height should be longer than the hypotenuse, so I just totally wrote it backwards. I need the radius. Do you see that right triangle then? This is 12, that's 15. So when you go to do this right triangle, you need to think about it. It's 12 squared plus the radius squared equals the slant height 15 squared. And I think that's a mistake we make. A lot of times we just throw these two numbers in here. My formula sheet actually has those exact letters on it. The radius squared plus the height squared equals a slant. These are the two sides of your right triangle. That's a hypotenuse. Okay, so how do we solve this? Well, that's 144, right? Plus r squared equals 225. And then what? Okay, I can do that. That gives me 81. So you told me to subtract the 144. I get r squared equals 81. So what does r equal? The square root of 81 is 9. Okay, so I'm going to use that r is 9. I'm not using the height. I'm using the slant height of 15. So plug it in. Pi times the radius of 9 times the slant height of 15 plus pi times, what's my radius? 9 squared. All right, clean it up. 9 times 15, 135 pi. 9 squared, 81. Keep the pi. And then take 135 and 81. I'm double check my math. 216. That's my exact, guys. Just add those up. They're like terms. 216 pi, and it should be inches squared. Now throw that in the calculator. What's my approximate? 216 times pi. Nearest tenth. That's what we're sticking with for the whole worksheet. 678. Yeah, 678.6. And it'd be inches squared. Okay, now flip it over. Let's talk about the back real quick. Now we're talking about the surface area of a sphere. That's on your formula sheet. Surface area of a sphere is 4 pi r squared. Okay, so we're looking at spheres and hemisphere. Give exact and approximate answers round in the nearest tenth. When you do the approximate, label your answers. All right, so looking at this one, you're given the radius, and that's what we need. This one, we're given the diameter, so what is my radius? Well, if the diameter is 32, my radius is? 16. Yep, and that's what I want. So the surface area, I'm just going to fill it in. 4 pi times 16 squared. Now, for the exact answer, you need the 4 and the 16 squared. You can't do 4 times 16. You got to do 16 squared times 4. So we're sort of taking the pi out and attaching it on the end. You can just type in 4 and then 16 squared, just like that. And then don't forget, it's pi. So you have 1024 pi. That's it, one step. 1024 pi, and what would be my label? Meter squared. All right, the approximate. Take that. I would just honestly hit times pi, but I'm going to take 1024 times pi just to show you. And we get 3,216.99. So that 9 is going to kick this up, so it's going to be 3,217. So watch that rounding, meters squared. All right, that's what I wanted to show you there. We're talking about a hemisphere, and I actually made a mistake yesterday. No one called me out on it. The last problem with the spheres was about a hemisphere, and bless you, and I forgot to take half of it. So anyway, when you do the hemisphere, you're going to do the same thing, but since it's a hemisphere, you're going to take half of the 4 pi r squared. Now it says radius with the great circle. Okay, the idea of the great circle is when you look at a hemisphere, the bottom of the hemisphere, that's the great circle, okay? And so that's what they're telling you. It's really the center out is 8 yards. So you're going to put that in and you're going to get the exact and the approximate. What I want to jump down to is number 13. Okay, so both of these give you the radius. Number 13 says a sphere with the area. Now this is a whole sphere with an area of 28.6 inches. So we're going to need to find the radius, which they really didn't ask you to find the radius, but we will. So if surface area of the sphere is 4 pi r squared, we have the surface area is 28.6, and that equals 4 times pi, and we're looking for r. So what are we going to do here? Well,
divide 4 to both sides.
I'm actually going to divide the 4 and the pi at the same time. Let's throw out the problem with this asking for an exact answer is the fact that we already have that decimal. Let me see something here. 28.6. Yeah, that, I mean, we'll do it. No. I was just seeing if we can get the exact answer, but it's not going to be really pretty. So I'm going to throw out the exact answer because it's truly not proper to have that. If you take 28.6 divided by 4, you get 7.15, and then you'd have divided by pi. But the next thing you're going to do is take the square root of both sides, and it's not proper to have the square root of a decimal, let alone pi in the denominator, because it's not rational. That's above what we've done. You know, we're going to get into that algebra, but that's above what we've done so far. So I am just going to take 28.6 and divide by pi. Now here's the problem. If you do this, 28.6, and you divide by 4 pi, you have to understand your calculator is going to take 28.6, divide it by 4, and then multiply the answer by pi. I get this 22.46. That's not right. If you take 28.6 and divide it by 4, hit enter, and then divide that by pi, you get a very different answer. You get 2.28. I'm rounding. Okay, so when you put this in the calculator, you'd have to know to put it in parentheses. 28.6 divided by 4 pi, and you see now we get that same 2.27. It's really easy to get that wrong. So actually maybe you're right when you said divide by 4, and then we come back and divide by pi, unless we put it in the calculator correctly. All right, now that's r squared, so what do we need to do? Take the square root of it. Now, I'm going to use my answer, so I'm going to hit square root of the answer. That way I have a more exact, and that is 1.5 is what we're going to round it to. That is in no way an exact answer. And it'd be 1.5 inch radius. So picture your sphere. You found the radius to be about 1.5 inches. That's what you found. That's not exact. We rounded it. We cut off the rest of the numbers. All right, so that is what I wanted to show you.